We're going to solve quadratics by completing the square. So with a quadratic set up as x squared plus bx equals c, so your constant, the number is on the right, you're going to complete the square. So to complete the square, you're going to find the b term, the value or the b value, the coefficient of x. You're going to divide it by 2 because the b value is a coefficient of x. Then in step 2, you're going to square the answer from step 1, and you're going to add the answers from step 2 to both sides of the equal sign. From there, we will solve for x. So we're going to do a couple problems together. So on this first one, we're going to start by finding the b value. It's already in x squared plus bx equals c form. So we just need to find the b value. That's the coefficient of x, which is 6. We're going to divide it by 2 and then square it. Well, 6 divided by 2 is 3, and 3 squared is 9. So I'm going to add 9 to both sides of the equal sign. Okay, so I have x squared plus 6x plus 9 equals 7 plus 9 gives me 16. So it's completing the square because it makes the left side a perfect square. So I can factor it into a perfect square. Square root of x squared is x, plus the square root of 9 is 3. If I refactor this, this means x plus 3 times x plus 3. I would get x squared plus 6x plus 9. I'm creating that perfect square over here. That's what completing the square does. So I can get a perfect square, x squared plus some number, take the square root of the first term, so the x squared term, take the square root of what you added to both sides. So this is equal to 16. So now we're going to solve for x. First thing we need to do, we want to get x by itself. Because this entire thing is squared, to solve, you have to do the opposite operation to both sides. Well, opposite of squaring is taking the square root. So we are going to take the square root of both sides. Okay, so taking the square root of a square, well, they undo each other. So we're just left with x plus 3 is equal to, square root of 16 is 4. But because we had a squared term, so we took the square root of a squared term, if you have something squared, you don't know if it was originally positive or negative. Because say that positive 3 squared is 9, but negative 3 squared is also 9. So because we took the square root of a squared term, when we take the square root of the right side, you're going to have to say it could either be positive or negative. You always have to put that in there. Now we're just going to solve for x for either case. So you have x plus 3 is equal to positive 4, and you're also going to solve for x plus 3 equals negative 4. Here I'm going to subtract 3 on both sides, and x equals 1, because 4 minus 3 is 1, and subtract 3 on both sides. X equals negative 4 minus 3 is negative 7. So I solve for x. Remember, it's a quadratic, so it's going to have 2 answers, and we solve by completing the square. So that's the most basic kind. I'm going to do one that's a little more complex. So this one isn't in the nice, pretty, just x squared. I have that number that's multiplied by x squared. First thing I have to do is get rid of that. Well, it's multiplied by x squared, so opposite is to divide. So I'm going to divide everything on both sides by 2. 2 divided by 2 is 1, so I have x squared plus 5 halves x plus 2 divided by 2 is 1 equals 0 divided by 2 is 0. All right, it's still not in the correct form because I need this constant on the right side of the equal sign. So I'm going to subtract 1 on both sides, and I get x squared plus 5 halves x equals negative 1. Okay, so now I can figure out what that, I'm going to complete the square. I can figure out what that b value is, which is 5/2, I'm going to divide it by 2 and then square it. Well, it is a fraction, so let's think about this. So my b value is 5/2. I'm going to be dividing it by 2 and then I'm going to square it. Well, when you divide by a fraction by a fraction, well, let's make this 2 into a fraction by putting a 1 below it. Remember, you do keep it, change it, flip it. So you keep your first fraction the same, change division to multiplication, then flip the second fraction over. Now I can multiply. 5 times 1 is 5, over 2 times 2 is 4, and I'm going to square that. Remember, when you're squaring, you have to square each. So 5 squared is 25, over 4 squared is 16. So we are going to add 25/16 to both sides. So this reduces to x squared plus 5/2 x plus 25/16 is equal to, let's see, -1 plus 25/16. Well, -1 is -16/16 plus 25/16, which leaves me with positive 9/16. All right, so now my left side is a perfect square. Square root of x squared is x plus square root of 25/16. Well, when I squared 5/4, I got 25/16. So taking the square root of 25/16, well, I know it's just going to be 5/4. So I have 5/4 squared is equal to 9/16. I haven't done anything to the right side yet after I added my 25/16. This is where I start solving for x. Because the left side squared, to undo that, I have to take the square root, but anything we do to one side, do to the other. Squaring and square root undo each other, so we have x plus 5/4 is equal to, all right, you have to take the square root of each individually when you have a fraction. So we're going to do the square root of 9 is 3 over the square root of 16 is 4. Remember, what number times itself equals that value. But because we took the square root of a squared, we have to have that plus or minus in front of the right side. And it doesn't mean the top's positive, bottom's negative. It means that we have to consider both cases. So we're going to solve for x using both cases. We have x plus 5/4 equals positive 3/4, and x plus 5/4 equals negative 3/4. Here, subtract 5/4 on both sides, and we get x equals negative 2/4, which is the same thing as x equals negative 1/2. All right, then we have this one where we need to subtract 5/4 on both sides, and we get x equals negative 8/4, which is negative 2. Negative 8 divided by 4 is negative 2. All right, so that's when we have fractions. I'm going to do one more. This one's slightly more complex just because of what we have to do. All right, so on this one, we're actually going to have an imaginary number on this one. So I don't have to divide by anything, and it's in the form x squared plus bx equals c, so all I'm going to do is complete the square to start with. So I'm going to say my b term is 4, so I'm going to divide it by 2 and square it. 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add 4 to both sides. So here we have x squared plus 4x plus 4 equals negative 24. All right, so this is a perfect square. Square root of x squared is x, plus square root of 4 is 2, and that's squared because I need to have x squared, or x plus 2 times x plus 2 in order to get back to this original quadratic over here, equals negative 24. All right, we're going to start solving for x. So in this case, we have to take the square root of both sides to start solving for x. Square root and square root undo each other, so we have x plus 2 equals plus or minus square root of negative 24. All right, so we have that negative underneath. I'm going to bring this down to the bottom. I'm just going to figure out square root of negative 24. All right, so if I break down negative 24, that breaks down to negative 1 times 24. 24 breaks down to 2 times 12. 12 is 2 times 6. 6 is 2 times 3. That means this is the square root of negative 1 times 2 times 2 times 2 times 3. Square root of negative 1 is just I, so I'm going to bring that out. I have 2 times 2, so I'm going to bring a 2 out. And I'm left with a 2 times 3. I can't bring anything out. So this actually reduces to 2I times the square root of 2 times 3 is 6. So that's what this right side reduces to. So this is just my work. I'm going to put in a little bubble so it doesn't interfere with my other work. So I know that x plus 2 is equal to plus and minus. This part reduced to 2I times the square root of 6. So I have an imaginary number, which is fine. I'm just going to start solving for x. I'm going to have two different cases. X plus 2 equals positive 2I times the square root of 6. And x plus 2 equals negative 2I times the square root of 6. So in this case, I'm going to subtract 2 on both sides, and I get x equals, I'm going to put my negative 2 in front, negative 2 plus 2I times the square root of 6. This one, subtract 2 on both sides, and I get, that is a negative 2I times the square root of 6, because we did the positive here, so that one is the negative. So I get x equals, I'm going to put that negative 2 in front, minus 2I times the square root of 6. So they're very similar. One's just plus and one's minus. Okay, so I'm going to have you try 3 that are very similar to the 3 that I just did with you. When you're ready, come back for the answers and I will go through them with you. All right, so first one. All right, I'm finding what I add to both sides. So 10 divided by 2 is 5, and 5 squared is 25. So I'm going to add 25 to both sides. That should be a 5. So we have x squared plus 10x plus 25 equals 9. Okay, so I completed the square. I'm going to factor this side to x plus 5 squared equals 9. I have to take the square root of both sides, and we get x plus 5 equals plus and minus 3. So x plus 5 equals 3, and x plus 5 equals negative 3 are my two options I need to consider. Here I'm going to subtract 5 on both sides. X equals negative 2 are my two answers that I need to find. So x plus 5, so subtract 5 on both sides, and x equals negative 8. So my two answers are x equals negative 2, x equals negative 8. Hopefully you got those. Next one, more fractions. We're going to divide by 2 throughout the entire problem. And we get x squared plus 7 halves x plus 3 equals 0. All right, I still have to subtract 3 on both sides because I have to get my coefficient over on the right. So we have x squared plus 7 halves x equals negative 3. All right, so I have to do 7 halves divided by 2 is 7/4. So I have to do 7/4 squared is 49/16. So I'm going to add 49/16 to both sides. All right, so we have x squared plus 7 halves x plus 49/16 is equal to, all right, negative 3. Let's see, if we convert that into 16ths, that would be negative 48/16. So negative 48/16 plus 49/16 is just 1/16. All right, so now I'm going to factor. This becomes x plus 7/4 is equal to 1/16. 1/4 squared. I can't forget that that side is squared because it's multiplied by itself. I'm going to take the square root of both sides. We have x plus 7/4 equals square root of 1 is 1, square root of 16 is 4. We have to have that plus and minus in front. So I'm going to solve for both. We have x plus 7/4 equals positive 1/4, and x plus 7/4 equals negative 1/4. So here we're going to subtract 7/4 from both sides, and we get x equals negative 6/4, which is negative 3/2, or negative 1/2. Okay, here subtract 7/4 from both sides, and we get x equals negative 8/4, which is the same thing as x equals negative 2. All right, one more problem, and then we're finished. Okay, so this one, 4 divided by 2 is 2. 2 squared is 4. So we're going to add 4 to both sides. We get x squared plus 4x plus 4 equals negative 18. Factor this side, we get x plus 2 squared equals. All right, so if I break negative 18 down, I get 3 times 3 is 9 times 2 is 18. So I know I can factor out a 3. Oh, sorry, I was already factoring. I'm just going to bring it straight down because I forgot to tell you I was taking the square root. So I have x plus 2 equals square root of negative 18. Okay, we have plus and minus. Square root of a negative is I, so I'm going to bring my I out. Okay, but I was trying to do the square root of 18. 3 times 3 is 9. 9 times 2 is 18. Meaning I can bring a 3 out. So it's 3i square root of 2. All right, so I'm going to solve for both cases. X plus 2 equals 3i times the square root of 2. And x plus 2 equals negative 3i times the square root of 2. Subtract 2 on both sides for both cases. And x equals, I like to put the number in front, negative 2 plus 3i times the square root of 2. And x equals negative 2 minus 3i times the square root of 2. Hopefully you were able to solve all of those.